On my home planet, the word Soh-Cah-Toa means I love math. And the beautiful thing about this word is that not only does it mean I love math on my home planet, but it also allows us to work with trigonometric ratios. So it's a very cool thing. We're continuing on with our right triangle stuff. So Soh-Cah-Toa, the spelling of this word is oh so important. It's Sohcahtoa. And we'll get in, obviously we'll get into more of what this means and how it breaks down and how it will help us with trig. But at this point, let's move on and take a look at some of the basics. We have sine is one of our trig functions, cosine, and tangent. So those are the three that we're going to be talking about today. We may end up pausing depending on the length of the video, but we're going to at least look at these basic trig ratios. So the OH, the AH, and the OA each go with the three different trig functions that you see here. Even though it's spelled sin, it's pronounced sine. It's actually an S-I-N-E. Cosine is C-O-S-I-N-E. And tangent is T-A-N-G-E-N-T. And they're just shortened to these three. You've probably seen these buttons on your calculator if you don't have any other experience with them. And a scientific calculator, you're all supposed to have a graphing calculator for this class anyway, will certainly come in handy and will just about be a necessity at this point. So we have sine, cosine, and tangent. Sine is the opposite over hypotenuse. Cosine is adjacent over hypotenuse. And the tangent is opposite over adjacent. Now, this may not mean a whole lot with me just saying it, but we'll get into the diagrams and the pictures of the whole thing. So we'll get it all worked out. So O is the opposite side, A is the adjacent, and H is the hypotenuse. The hypotenuse, remember, is always the side that's across from the right angle. So a trigonometric ratio is a ratio of the lengths of two sides in a right triangle. So we have two legs and we have the hypotenuse. Depending on which angle we're talking about, you know, if we're looking at this angle, the side that's opposite that is right here. The side that's adjacent would be right there. And the hypotenuse is the hypotenuse. That's the thing that doesn't change. The other legs can change because if we're talking about this angle, this little green angle, the side that's opposite that is the leg that's green. So when we have the two legs, any ratio of the legs of a triangle, we're going to be using the tangent. So if you remember back to the toa, the tangent part, Soh-Cah-Toa, toa is a way to remember tangent. So the tangent of an angle, I'm going to call it theta. It's a typical angle way to talk about an angle. Tangent of theta is equal to the opposite side. So I'm going to throw in some letters here. I'm going to call this L and M. And if this is theta, the tangent of theta is the opposite side, which is L, over the adjacent side, which is M. Remember, tangent doesn't have a hypotenuse involved at all. The opposite over the adjacent. If we decided to choose a different angle, let's call this beta, the tangent of beta is equal to the opposite, which is opposite of the beta is M, and the adjacent is the L. So the tangent of beta is M over L. Opposite over adjacent, Toa. Soh-Cah-Toa. So here's just a little more wordy version of the same thing. We have the leg that's adjacent to angle A. So this is angle A. The leg that's adjacent to it the leg that's opposite angle A. So the tangent of A is the opposite, which is segment BC, over the adjacent, which is segment AC. No hay problema. So let's practice this a little bit. We jump to practice. We'll jump back to that sine and cosine breakdown. So it says find the tangent of D and the tangent of F. Write each answer as a fraction and as a decimal rounded to 4 places. So if that's our goal, we have the tangent of D. So that's here. So tangent of D is equal to the opposite, which is 60, over the adjacent, which is 45. Now, since we're talking about tangent, is that 75 ever going to come into play in this situation? Yeah, you better be saying no, because that's a hypotenuse, and tangent is Toa, opposite over adjacent. The hypotenuse can never be either of those. So the tangent of E, we're not going to do, right? That's a right angle. So we need the tangent of F. Tangent of F. So that is, let me put it in a different color just to go from here. So the tangent of F is equal to the opposite, which is 45, over the adjacent, which is 60. So the tangent of D is 60 over 45. The tangent of F is 45 over 60. So you can write that as a fraction and also as a decimal. Now it says find the value of X. So we're looking for one of the lengths of the legs. The hypotenuse isn't involved here. So Toa, tangent of this angle. So the tangent of 17 degrees is equal to the opposite, which is 9, over X. So the tangent of 17 equals 9 over X. When you start messing with this with your calculator, you do need to make sure your calculator is in degrees and not in radians, because we are using degrees currently. So since that's the angle we're going with, talking about degrees and not radians, make sure it's in degrees. So as you work this out, just some basic algebra, to get X by itself, X is equal to 9 over the tangent of 17. So you can work that out on your own. 9 divided by the tangent of 17, you're going to get a value for X. Find the height of the flagpole to the nearest foot. Well, we need to look here. Do we have anything with the hypotenuse? Doesn't look like it. Looks like we have 2 legs and an angle. So the 2 legs, so we're looking at Toa. So the tangent of 65 degrees is equal to what? Hopefully you have time to work that out. The side that's opposite that 65 is the X. The side that is adjacent is the 24. So that means that X is equal to 24 times the tangent of 65. So you can work that out. You just do 24 times the tangent of 65. So the tangent of 65 degrees is 2.1445. So you're doing 24 times that to get the height of the flagpole. So that's approximately equal to 51.5. So it's about 51.5 feet for the height of the flagpole. That's all just by setting up this ratio. Back to the special right triangles. Use a special right triangle to find the tangent of a 45-degree angle. This is where you embrace your inner geek and you sketch a 45, 45, 90, because this is how you doodle. 1, 1, and radical 2. 45, 45, 90. 1, 1, radical 2. So the tangent of a 45-degree angle. That is the opposite. Tangent of 45 is the opposite side, which is 1, over the adjacent side, which is 1. So the tangent of 45, that's right, 1. The tangent of 45 equals 1. That's a beautiful use of right triangles. I'd just be able to sketch that out and be able to look at that connection. Right, so time for sine and cosine. So sine and cosine is exactly what you would guess. Sine, it's Soh-Cah-Toa, and then it's Toa that we just worked with. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. If we're talking about the sine of A, in this particular case, it's opposite, which is BC, over the hypotenuse, AB. Opposite over hypotenuse. For the cosine of that same angle, the cosine of angle A is the adjacent over hypotenuse. So it's AC over AB. So let's just jump right into it, because I think if you get one of these, you get the idea. It's just a matter of looking at the triangle and making sure that things are going to work out for you. So find the sine of A and the sine of B. Now, remember, it's not asking you to find the angle at this point, so we're just finding the sine of A and the sine of B. So write each answer as a fraction and a decimal rounded to 4 places. So the sine of A is equal to sine, let's think. Sine, Soh-Cah-Toa. Soh-Cah-Toa. This opposite, which is 40, over the h, which is the hypotenuse, is 85. So the sine of A is 40 over 85, which of course can be simplified. So go ahead and simplify that fraction and then round it as a decimal to 4 places. You don't need to stay here, hang out watching me do that. We now have the sine of B. Sine of angle B. Sine is opposite over hypotenuse. So it's opposite, which is 75, over the hypotenuse, which is always the same, which is 85. Again, that can certainly be simplified, so go ahead and simplify it and then write it as a decimal rounded to 4 places. You'll see why we're rounding these to 4 places in a little bit. But for now, just reduce those fractions, or simplify those fractions, rather, and write them as a decimal rounded to 4 places. Find the cosine of P and the cosine of R. Cosine, C, Soh-Cah-Toa. Soh-Cah-Toa. Cosine is adjacent over hypotenuse. So the cosine of P is equal to the adjacent side. That's the one that's next to it. Has to be 5 radical 5 over the hypotenuse, which is 15. That can certainly be simplified. 5 goes into 15. So we get radical 5 over 3, and then you can write that as a decimal out to 4 decimal places. And now we have cosine of r. This time we want the cosine of r. Cosine, ca, C-A-H. Cosine of r is adjacent, which is 10, over the hypotenuse, which is 15. So of course that simplifies very nicely. So you can simplify that fraction and then write it as a decimal stretched out to 4 decimal places. Cruise along here. A rope staked 20 feet from the base of a building goes to the roof and forms an angle of 58 degrees with the ground. To the nearest tenth of a foot, how long is the rope? So we start looking at what we have here. We're looking at this angle. We know one leg. And what is it that we're trying to find? Well, I guess we want to know the length of the rope. That's this one here. That's the hypotenuse because it's across from that 90-degree angle. So which trig function will use the adjacent side and the hypotenuse? So the adjacent side and the hypotenuse, which trig function will do that for us? Soh-Cah-Toa, C, adjacent over hypotenuse. So if we take the cosine of 58 degrees, that's going to equal the adjacent side, which is 20, over, we don't know. So X or H or whatever you want to, or L or whatever letter you want to use. So if we go with the X, so simple cross multiplication gives us X equals 20 divided by the cosine of 58. So you just do 20 divided by the cosine of 58. And that ends up being approximately equal to 37.7 feet for the length of the rope. There you have it. All right. Another type of example, same basic idea. Pilot's looking at an airport from her plane. The angle of depression is 29 degrees. So the angle of depression is this right here. And because these lines, like the horizon, or that level flight and the ground are 29, that means that this angle is also 29 degrees. So this angle here would be called the angle of elevation. This would be called the angle of depression. And we want to know the length, how far is it from the airport? So the airport's over here. We know how high the plane is, and we know the angle. So, and that height represents the side that's opposite that 29. So we need the O, or we have the O, and what we want to know is the hypotenuse. So we need the O and the H. Soh-Cah-Toa, so we need an S on there. That's the sine of 29 degrees is equal to the opposite, which is 10,000 feet over X. So that means that X is equal to 10,000 divided by the sine of 29. So if you do 10,000 divided by sine of 29, you get approximately 20,627 feet is her distance from the airport. One more, going to throw in another special right triangle. Find the sine and cosine of a 45-degree angle. Again, boom, boom, boom. 45, 45, 90, 1, 1, radical 2. Love special triangles. The sine of 45 equals the cosine of 45 equals the sine is the opposite, which is 1 over the hypotenuse, which is radical 2. Cosine is 1 over the hypotenuse, which is radical 2. Can we leave that as 1 over radical 2? Not right now, you can't. Maybe later on. So that means that we have to multiply top and bottom by radical 2 over radical 2. So we have just pull these over to the other side. We have to multiply top and bottom by radical 2 to rationalize the denominator. We end up with radical 2 over 2. So the cosine of 45 is radical 2 over 2. It's the same over here, radical 2 over 2, because radical 2 times radical 2, we all know, is 2. So there's the value. Cosine and sine are the same for 45 degrees. So that's it on Soh-Cah-Toa. Hope you enjoyed it. Best of luck. Some